Season 1, Episode 13 asks us to find the stationary points on this curve, and it says to do that using the second derivative. So a very quick refresher on the second derivative. If the second derivative is positive, we have a minimum, and if the second derivative is negative, we have a maximum. If the second derivative happens to be 0, you're looking at a horizontal point of inflection, something like y equals x cubed. Alright, so all stationary points, as has been discussed previously, are when the first derivative is 0. So the first derivative is 0, where the gradient is 0, you're going to have some sort of stationary point. So let's do that. Here's y, let's find dy dx. Power comes out the front, that'll be 6x squared. Power comes out the front, take 6x, power's just 1, leaves us with 12. We lose a constant, derivative of a constant is 0. So at this point, we set dy dx to be 0 to find stationary points. So I'm just going to write that with 0 at the front. I see a nice common factor in there. I can divide everything there by 6. So if I divide both sides by 6, I'm going to have something a little bit easier to manage. So I'll do that. 0 equals x squared, take away x, take away 2. Now here, it's our old friend of quadratic again. I have a particular way of doing it. I don't mind which way you do it. Full grades for doing it manually though. So here I need something that's going to multiply to negative 2, add to negative 1. So it's got to be a negative 2 and a positive 1. So from that, I'm going to get x take 2, x plus 1. So therefore, either x take 2 equals 0 or x plus 1 equals 0. X equals 2 or x equals negative 1. Alright, so our stationary points are at x equals negative 1 and x equals 2. Now that's fine and well, but they wanted us to use the second derivative to find the nature, so we better do that. So second derivative, that's got some weird terminology in it. We use d2y over dx squared. So where was dy dx? So dy dx was back up here. I'm now going to derive that again. So I'm going to get 12x subtract 6. That's all that's going to be left. So at x equals negative 1, if I put negative 1 in that formula, I'm going to get negative 12 take away 6, it'll be negative 18. So therefore, at x equals negative 1, it's going to be a maximum. So we have a maximum at x equals negative 1. Over here, at x equals 2, if I put 2 in this formula, I'm going to get 24 take away 6, leaving me with a positive 18. Positive means I have a minimum. The other thing here is, what did the question ask? It actually said the stationary points. When we talk about points, we usually expect that we've got the y coordinate as well. So I probably should work that out. So at x is negative 1, here we've got our formula that turns an x coordinate into a y coordinate. So y equals 2, negative 1 to the power of 3, take 3, negative 1 squared, take 12, negative 1, take 7. So you've got to put all that together. Negative 1 to the power of 3 will still be negative 1, so it's negative 2. Negative 1 squared will be a positive 1, but we've still got to take away 3 there. Here, a negative 12 by a negative 1 will end up with a plus 12. Take 7. Negative 2, negative 5, positive 7, 0. Is that right? Negative 5, is that? Yeah, it looks like we're going to get 0. So therefore, we are saying that there should be a maximum at negative 1, 0. X coordinate, Y coordinate, we found out earlier it's a maximum. At x equals 2, we've got to do the same thing. We've got to put 2 in that big formula. So 2 to the power of 3, take 3, 2 squared, take 12, 2, take 7. Alright, so 2 to the power of 3 is 8, so that'll be 16. 2 squared is 4. 4 times 3 is 12. 12 times 2 is 24. Take 7. Oh, that's going to be a bit of a mess, isn't it? Alright, 4, negative 20, negative 27. Therefore, minimum at 2, negative 27. Now you could always check that on your graphics calculator.